Gallagher Fluid Seals presents this training module on fluoroelastomers. Fluoroelastomers are high-performance elastomer materials used in the chemical process, semiconductor, aviation, and other industries where seal resistance to aggressive chemicals and high temperatures is needed. The following slides will discuss considerations when choosing a fluoroelastomer, including, but not limited to, temperature rating and chemical exposure. These last few slides review some cautions when selecting elastomers. This first chart shows the temperature rating for 7 different elastomer materials. By now you will recognize that the bottom 3 elastomers on the chart are fluoroelastomers. On this chart, the green bar shows the standard temperature performance range for each type of elastomer. This information is typically shown in product literature. However, these results are from testing these products in air. Factors such as temperature cycling, temperatures above the suggested upper surface limit, and chemical exposure will reduce the performance life of these products. So be conservative when looking at the temperature range of elastomers. Next, be very cautious when selecting elastomer blends. For example, an elastomer that is a blend of ethylene propylene rubber, EPR, and an FKM may be called a fluoroelastomer in a supplier's product literature. The product's physical properties can be in the expected range for a standard elastomer seal. Unfortunately, the performance will be different from a fluoroelastomer produced using 100% FKM polymer. In most cases, blends often have the worst properties of each individual product. The next 2 slides show examples of this. This chart compares a product made with 100% FKM polymer to several fluoroelastomer blends at high temperatures. After heat aging at 1 week at 200 degrees C, the product made using 100% FKM polymer shows minimal hardness change. FKM blends with CR and EPR become so hard that they are too brittle to test. The blend with polyacrylate has a hardness change of 21 points. Elastomer products that become very hard or brittle lose their ability to seal properly. This slide again compares a product made with 100% FKM polymer to several fluoroelastomer blends in a harsh chemical environment. The exposure is 1 week in concentrated sulfuric acid at 70 degrees C. The product made using 100% FKM polymer holds up well with a volume swell of only 12%. The CR and EPR blends show a very large volume increase. A volume increase of 25% or more will often result in the seal overfilling the gland, extruding, and finally failing. In the case of the polyacrylate blend, the elastomer dissolves. Blends may be of interest because they are often lower in price than products using 100% FKM. However, extreme care must be taken when choosing a blend to avoid costly seal failures. When choosing a fluoroelastomer, there are a number of factors to consider. The application temperature is probably the most important. If the elastomer cannot handle the process temperature, then don't use it. Next, is the elastomer compatible with the process chemicals, including any trace chemicals in the process stream? Even trace chemicals may attack an elastomer seal and cause it to fail prematurely. Next, consider the physical properties needed for the application. Does the seal need to flex? Is there temperature cycling? Is there sufficient room in the gland for thermal expansion? If low temperatures or other specific performance characteristics are needed, specialty formulations may be required. Finally, take the time to understand the elastomer product performance and, in general, stay away from product blends. This is only one section of a much more detailed Fluoroelastomers Basics training module. To download the entire training module, please follow the link in this video or visit Gallagher's resources page.